You've probably done it before, right? You sit in a dark room, you stare into this strange-looking bowl, and you click a little button every single time you see a flash of light. Now, it feels kind of like a simple, maybe even a little tedious reaction test. But what if I told you that that simple test is actually creating a super sophisticated map of the connection between your eye and your brain? Well, that's visual field testing, and it is one of the most powerful tools we have in medicine.
So what can that little flash of light really tell us? I mean, come on, the answer is, it's pretty incredible. It's not just testing your eye. It's evaluating the entire superhighway of information that runs from your retina, along your optic nerve, and all the way to the visual processing center in the very back of your brain. Every single click is a data point on that map.
All right, so to really understand how this map works, we first need to define the territory. What exactly is a visual field?
Your visual field is quite simply everything you can see at any given moment without moving your eyes. So while you're staring at a single point, it's all that space, up, down, left, and right, that your vision covers. Think of it as your own personal panoramic window to the world.
So, what does a healthy visual field even look like? Well, picture this. It's like a wide, oval-shaped bubble of vision all around you. If you look straight ahead, that bubble extends inward, toward your nose, by about 60 degrees.
But here's the cool part. It stretches much, much further outward, toward your temples, a full 100 degrees. That's what gives us that incredible peripheral awareness. You know, seeing things out of the corner of your eye. Now, vertically, your brow bone kind of gets in the way, so it limits your upward view to about 60 degrees. But you can see much further down, around 75 degrees. So this whole oval shape is the invisible territory that the test is designed to map. And any change to its shape, well, that's a potential clue.
So now that we know the shape of the territory, how do clinicians actually map it? I mean, how do they find the borders of this invisible field? Well, it really comes down to two main techniques.
The classic way is called kinetic perimetry. Think of it as manually drawing the border. An examiner literally moves a little light from the outside in until you go, yep, I see it. But the modern standard, the one you've probably done, is static perimetry. This is the automated test. Instead of moving lights, a computer flashes stationary lights of different brightness levels all over the field. This doesn't just map the border, it measures the sensitivity of dozens of points inside the field. It creates a much more detailed picture, which is absolutely crucial for catching the early signs of diseases like glaucoma. Okay, the test is done, we have our map. But before we start looking for treasure, or, trouble, we have to make sure the map itself is accurate. And that starts with checking for reliability.
You know, the machine is pretty smart. It actually builds in a quality check. It watches for fixation losses to see if your eye wandered from that center point. It tests for false positives, catching you if you get a little trigger happy and press the button when there was no light. And it checks for false negatives, which is when it notes if you suddenly miss a very bright light in a spot where you just saw a dim one, which might mean you're getting tired. If these numbers are too high, the map's just not reliable, and the test has to be done again.
All right, with the reliable map in hand, we get to the most exciting part, the interpretation. This is where the real detective work begins, where we look for patterns, for clues hidden in the data that tell a story about our health. Now, the technical term for any defect or blind spot on this map is a scotoma. Sounds fancy, but it's really just a localized area where your vision is less sensitive than it should be. But here's the thing, the shape and the location of these scotomas are what matter most.
For example, take a look at an arcuate scotoma. This isn't just some random blob of vision loss. No, it follows the precise, elegant arc of the nerve fibers as they sweep across the retina. It's like seeing a shadow that perfectly outlines a hidden structure. This specific shape is a classic telltale signature of damage from glaucoma. Another huge early warning sign for glaucoma is something called a nasal step. It's a sharp, step-like drop-off in vision that perfectly respects the horizontal midline, but only in the nasal part of your field. Again, this isn't random. This specific pattern points directly to the kind of damage that glaucoma causes.
Okay, now let's totally shift gears. What if the defect isn't some small spot, but the loss of an entire half of your visual field? This is called a hemianopia. And when we see this, it tells us the problem probably isn't in the eye itself, but further back in the brain's complex visual wiring.
And this right here is where the test becomes an unbelievably powerful neurological tool. Take a bitemporal hemianopia.
That's the loss of the outer or temporal fields in both eyes. It basically creates a form of tunnel vision. This highly specific pattern points like an arrow to one single spot, the optic chiasm. That's the X-shaped junction where nerve fibers from each eye cross over. And you know what the most common cause for this exact pattern is? A pituitary tumor growing and pressing on that junction from below.
Then there's homonymous hemiopia. Now, this is the loss of the same half of the field in both eyes. So, for example, the entire right side of your visual world is just gone. This tells a clinician with remarkable precision that the problem isn't in the eyes and it isn't at the chiasm. It's behind it, somewhere along the optic tracts or in the visual cortex itself. This test can literally help pinpoint the location of a stroke or a brain lesion. It's incredible.
So, what's the big takeaway here? The crucial point is this. The visual field test is so much more than just a vision screening. It's a profoundly powerful diagnostic tool.
It really serves as this unique bridge between ophthalmology, the study of the eye, and neurology, the study of the brain. By carefully analyzing the patterns of vision loss, clinicians can detect, track, and locate problems anywhere along that incredible pathway, from the very front of your eye to the very back of your brain.
So let's end with this idea. The true power of this test is in its sensitivity. So many devastating diseases, both in the eye and in the brain, they first whisper their presence as tiny, subtle shadows on a visual field map. That simple flash of light you see in the dark isn't just a test, it's an early warning system, and it plays a critical role in protecting not just your vision, but your life.